Right, all of these guys are the same. On all of these, we are just changing all these into their exponential forms to figure out what's going on. So for this one here, you do need to know that if it doesn't say a base, it means base 10. Base 10 is our most common base, and so it's used so often that we just call it log. And in fact, here, if you were to type in log on your calculator, that means log base 10. So here, we just put it in there, and this then means 10 to the negative 2 is equal to x. You do need to know that negatives flip it, and then 10 squared is obviously 100. Here, again, we rewrite it. 7 to the negative 2 is equal to x. Again, we flip it, and then we square it. Here, 3 to the 4 is equal to 5x minus 4. So now we need to do that math. What 3 to the 4 is, what, 81? And then you just solve, just like algebra 1. So this is what, 85? And then 85 divided by 5 is our 17. And our last one, we have 9 to the x is equal to 1. The only thing that I can put in here that would make it a 1 is a 0. I can just check it. So say I'm like, I don't know, is that right? 9 to the 0 totally is equal to 1. So you can always just check it on there. Oh, I forgot the 3. Where did the 3 come from? 3 would go up here. So we would have there. So this would be 3 there, but that's still just 1. That doesn't really change anything on that. Okay, let's go ahead and look at these guys here. The reality is this is multiple choice, and you could guess and check on these. So I know a lot of students said, hey, this is 6 squared is equal to x squared plus 9x. The problem with guessing and checking for at least a lot of my students is that they guessed and checked and got 1 and didn't recognize that there were select all other ones that also would have worked. So I'm going to just solve it for you to show you how you would do that. This would be what, 36 equals x squared plus 9, because you guys have done this for ages. This is that's why we factor, that's why these were talking about like our roots and all those types of things. So we've got our diamond, negative 36 and 9. So that would be, what, 12 and 3? So we would get x plus 12 and x minus 3. Did I not do that right? 6 squared. $36. Oh, this is probably a bad problem. Let's do that because this is what you're going to see on your test. There you go. So then we would get x is equal to negative 12 and x is equal to 3. So we would say this would be an answer and that would be an answer. And when you plug it in here, you would get positive 144 for this, and then minus 12 times 9, which is equal to 36. If you plugged in the 3 here, you would get 9 plus 27, which is also 36. So both of those would be the answer. Okay, let's go ahead and look at these guys down here now. So for both of these, in order to write this as a logarithm, I need to get this part all by itself. So the first thing we do is reverse PEMDAS. So I need to move the 2 over, and then I need to move the 3 over. Even though this is 3 times 5, and you're like, yay, it's 15. No, it's not. You need to not do that first because multiplication does not come before exponents. So we move the 2 over. We get what, 27? We divide both sides by 3. We get 5 to the x is equal to 9. Now looking here, I know that this answer is going to be more than 1, but it's going to be less than 2. So I should know that walking into it. There are 2 ways that you can approach this problem. One, which is what we first learned in class, is that you would apply a log to both sides. And then this is the power rule, which means it comes out in front. If you do that, we then just need to get x by itself. So you're going to divide both sides by log. You're going to plug that into your calculator carefully. You do need to when you plug that in, log of 9, you do need to end or close that parentheses before you do log of 5. Otherwise, you would get log of 9 divided by log of 5 and totally not the same answer. So we would get 1.37 as our answer. The other approach to this is to write this as a logarithm, which is log base 5 of 9 is equal to x. And then the way you plug that in your calculator is log of 9 divided by log of 5, which is exactly the same thing we did here. So that would give you your answer. Now, for this one here, don't be frightened that it's an e. An e just is a decimal, so we're going to deal with it when we get to it. So you're going to, here, it's already by itself. You don't have to move anything over. So we're just going to do log base e of 1640 is equal to 2.5x. We're going to plug that into our calculator. Now, I'm doing this because this is what we've learned in class. Next year, math analysis, you'll recognize that log base e is actually a thing that you can use, but this is what we're doing. There's no reason to do anything new at this point, so we're going to go ahead and just plug that in. So we're going to do log of 1640 and parentheses divided by log of e. So I do need to find the e button, which I have. We get this answer here, which is 7.40. But here's the thing, I still don't have x by itself. So we need to make it that way. This was division. It was multiplication, so we're going to do division. So I'm now going to divide by 2.5 in my calculator, and I would get 2.96 as my answer. Now, here, since I have it in here, I'm just going to go ahead and make sure that this is the answer. So I'm going to do e to the 2.5 times, and I'm going to go ahead and put in that answer. So I'm going to do second, and then the minus button actually gives us the answer of what it is that we had before. And I see now that is exactly the same as this. The same thing up here, you totally could have checked that answer there. That was, what did we plug in? Log of 9 divided by log of 5. So log of 9 divided by log of 5 is this guy here. And so right here, I could have said 3 times 5 to the answer, and then plus 2, and I totally get 29. So when you're done, you can always just check your answers to make sure that they're right. Okay, our last one, I need another paper here, is talking about depreciation. Now, notice that it does not say anything here about compounded continuously, compounded quarterly, anything. It's just a straight up multiplication problem. So we have our initial value. We have our multiplier. Now, this is how much is depreciating, so we need to have 1 minus 0.045, which would give us 0.955 as our multiplier. If it was an appreciation, we would have done 1 plus 0.045. So again, you've got to change it to your decimal. And then if I multiply it by this, I would get a crazy small number. We just want it to decrease by a little, so we're going to multiply it by something that's almost 1, but just a little smidge less than that. So this is t in terms of years. And what we're trying to figure out is exactly how long will it be that it reaches the 1,000. Now, I am asking exactly. We are asking that, so we are looking for a decimal. We are looking for showing your work, not plugging it into your calculator or guessing and checking or using your table. You can use that to check your work, but we are looking for logarithms. This whole point is about logarithms. So this now becomes exactly like these guys here. This is the one thing that needs to move. And so we're going to do that. So we're going to do 1,000 divided by 23,000. And we get this really awful decimal. So I'm going to leave that in my calculator because I'm going to use that in a moment. Right now, I'm going to go ahead and write this as a log. You can do log on both sides. Either way is fine. But if I'm going to write it as a log, that's what we're going to have. And then there's all this stuff. I'm leaving it exact because if I get a decimal right now, my answer will not be very exact. It will actually be very inaccurate. And so I'm going to go ahead and just leave it because right now what I'm supposed to do is take the log of this, all this stuff, and divide it by the log of 0.955. So I'm going to do that. I'm going to do log of the answer, meaning log of all of that stuff, and then divide that by log of 0.955. So I would get exactly 68.0978. Feel free to include as many decimals as you want. So if you were to look this up on your calculator, you wouldn't find exactly 68. You would have to be like, it's kind of 68. We're looking for exact, and our logarithms help us find that.